just going to go through this question. It was originally written with JavaScript, but you guys won't have JavaScript on your exam, so I've just converted it into Python. This Python code shows the definition of a recursive function called mystery. The final line of the code is displayed. The output returned when mystery is called with an argument of 4. So define mystery. So this is your function defining your function. You bring in n. So we're passing in 4 to begin with. And I'm just going to step through this code here now. So I'm just going to use the little debug tool just to work through it. And I'm just going to step in using this little arrow here. So when we pass in 4, n is going to become equal to 4. So if n is equal to 4, and of course we know, if n is equal to 0, so 4 is not equal to 0, that is false. So it skips to this line of your code here. So it says return n multiplied by the mystery of n minus 1. So n, in this scenario, is equal to 4. We begin with, and we multiply it then by the mystery of n minus 1. So 4 minus 1 is 3. So now we need, in order to get the answer to that part, we need to get the mystery of 3. So I'm just going to take note of this. The mystery of 4 equals 4 times the mystery of 3. And now we need to find out, well, what's the mystery of 3? So we work through our code here. And is n equal to 0? No. That's false. So n is now 3. So it's 3 times the mystery of n minus 1. So that becomes the mystery of 2. So the mystery of 3 is 3 times the mystery of 2. In order to figure out that, we would need to find out, well, what is the mystery of 2? So we continue with our code. So is n equal to 0? No, it's not. So n is equal to 2, so that statement is false. And therefore, n is 2 multiplied by the mystery of n minus 1. 2 minus 1 is 1. So the mystery of 2 is equal to 2 times the mystery of 1. Well, we need to figure out what the mystery of 1 is in order to get the answer to that. So the mystery of 1 is what we're going to look for next. So is n equal to 0? No, it's not, because n is equal to 1. So that's false, so we jump to this line. So the mystery of 1 is equal to 1 minus 1, which we know is 0. So the mystery of 1 equals 1 multiplied by the mystery of 0. Now let's find out what is the mystery of 0 in order to answer this question, the previous one. So now we step into that. Well, is n equal to 0? Actually, yes, it is this time. So n is 0. So that's correct. That's true. So we're going to return 1. So now the mystery, let's have to go a little bit faster. The mystery of 0 equals 1. So the mystery of 0 equals 1. Then we can figure out what this answer here is. Mystery of 0. So it's going to be 1 multiplied by 1 equals 1. Well, when we know what the mystery of 1 is, so the mystery of 1 is 1, so it's going to be 2 multiplied by 1 here equals 2. I'm changing the color of my pen to make it a bit easier to follow. So the mystery of 2 then we know is equal to 2. So therefore 3 multiplied by 2 equals 6. And again we know that the mystery of 3 is 6. So 4 multiplied by 6 equals 24. So when we keep stepping through our code, it now has the answers, and it's doing it very quickly on Tani. But we keep working through it, it will return your answer to be 24. And it prints it down here, 24. So that's how it's stepping through it. So it has to go down and then it has to go back up, it calling itself within itself. That's what a recursive function is. So it's using itself within its own function.